Alright, let's wrap up a few more little important things before we move on. First of all, now that we just learned about default parameters and overloaded functions, here is something to look out for if you're ever going to be using both of them together, overloaded functions, with some of them having default parameters. Like for example, let's say we have these two functions over here, doStuff, with no parameters, and another overloaded function doStuff that takes one integer parameter which has a default value of 10, which means that if I call the function doStuff without passing in an integer, it will assign the default value of 10. Well, at least so we'd like to. But if you noticed, we have a problem of ambiguity over here. Because think about it, anytime I want to call this function doStuff and I don't pass in any parameters at all, you have to wonder which version of the doStuff function is it going to call? Is it going to call this one that has a totally empty parameter list, just like when I called it I didn't pass in any parameters? Or will it call this overloaded function and it will make use of the default parameter 10 because I didn't pass any integer into that function? Even if you got a lot of different parameters in this second version of the overloaded doStuff function, but if they all have default values to be assigned to the parameter if nothing is provided, and then when I call this function with no parameters, we're still confused. Which one should I call? This one that doesn't have any parameters at all, or this one and I should use the default values? So yes, this is a compiler error. If you ever do something like this, you will get a compiler error complaining that these two functions are ambiguous because when I call it without any parameters, it doesn't know which one to call. So just keep that in mind when you're doing function overloading and at the same time you're making use of default values for your parameters. This same issue would also apply to overloaded constructors of your classes. Over here, when I'm trying to create an instance of the class foo, the compiler doesn't know which constructor to call when it's creating this object, because this overloaded constructor has a lot of default parameters which it could use if nothing is provided. So the same rule applies, that you need to be careful about this problem of ambiguity. Do not make overloaded functions and overloaded constructors which will have a problem of ambiguity between them. Now, it's easy to understand how default parameters can be useful when you think about the plain old variable types like integer or float and stuff like that, that whenever I don't pass inside a value as the parameter, the program will make use of the default value instead and use that as if I passed it into the function. Now, what about pointers, references, and objects of your own classes that you invented? Let's just have a quick peek at what kind of default values you'd give to those kind of things if you're ever going to make a default parameter for those kinds of stuff. If you're ever going to have a function that's going to have a pointer parameter, which means that we are making use of the address of something in memory, you really want to be very careful with that, as we learned that there could be lots of problems with memory leaks, dangling and wild pointers if they do not point to a valid position in memory. Which means that obviously you'd never want to supply any sort of number as a default value for your pointer parameters, because you're never going to know any real memory address that you'd like to assign to this pointer to point to. So never ever play around with that. The only default value I'd ever think of supplying for a pointer parameter is the value of 0 to make the pointer null, which means that if I call the function and I pass in a pointer, then everything's fine. The function has received a valid pointer, which it will be pointing to the address of whatever it had, just like any old plain function that takes a pointer as a parameter. But in a situation where I call the function and I did not pass any pointer inside of it, by default I'd like that pointer to be null, to be pointing to nothing in memory, by assigning it the number 0 in the declaration of the function. The only other really weird situation about assigning a default value for a pointer is if you maybe created a global variable, which means it's a variable that's not limited by the rules of scope because it was created out in the open, not inside of any specific function, which, as we learned, is not a good idea. So then I'd be able to assign the address of that global variable to be pointed to by this pointer by default if I don't pass anything into this function when I call it. But as we learned, we should avoid all that at all costs. Now, what about a default value for a reference parameter? Now we are really playing with fire because a reference can never be assigned to null. There's no such thing as a null reference. As we learned, a reference must always be referring to some valid object. And that's why, as a rule, you should never really make a default value for a reference parameter of some function. Unless, again, you had some global variable you made before to which this reference can refer to in case nothing else is passed into this function that the reference should be referring to. But again, global variables is not recommended, which is why you should not make any default values for your reference parameters, and you should always make sure to have a valid object to pass into this function that takes a reference, never relying on any default parameter. Now, what about a default value for a parameter of your own types that you created? Like if I created a class ogre over here, and I'm declaring this function do stuff that it's going to be taking in as a parameter an object of my ogre class. So what kind of default value can I possibly give to this instance of my class ogre? Well, actually we're going to learn about this in a different video about operator overloading, because we first need to learn how to make it possible to use the assignment operator with your own classes. Like if I made one instance of ogre A and another instance B, we need to learn what does it mean and how does it work to assign one instance of this ogre to another instance. So we're going to leave that for another time when we learn about operator overloading. For now, let's just wrap this up with one more little important thing. Let's look again at this line, using the standard namespace. As we learned, what this means is that once we included the IOStream file, it's like we asked permission to start making use of the stuff in that file by including it. But that's not enough. We need to ask permission again by announcing that we will be using stuff that's inside this big package or namespace that's called std. Now that was okay for the beginning, but from now on we are going to start worrying about a problem. And that problem is like this. Once we announce that we want to use everything that's inside the entire namespace standard, at this point there are thousands and thousands of different classes and objects that are made available to us to use, like cin and cout and lots of other cool stuff. Now, while that may sound pretty awesome, but at the same time we put on ourselves a major restriction. And that restriction is that we now are not allowed anywhere in our whole program to make a variable or a class or an object that is called cin or cout or any of the other stuff that's in the package in the namespace of standards. Because these names cin and cout are already being used, they are already reserved inside of the standard namespace. And we all know the rule that you cannot possibly make two variables with the same name. So if the word cin is already used, you cannot use it again for the purpose of your own variables and types or functions. Now you may think that it's okay, I can live with that, but it's a bad habit to get into, especially when you're going to be making bigger and larger projects. So the solution is simply to, first of all, let's delete this line using the standard namespace. And from now on, anytime you want to make use of something that's from the IOStream file in the standard namespace, you are first going to type std and 2 colons. such as over here, std2 colons cout, std2 colons cin, and so forth.